This is Unit 4, Section 1. We are still in rational functions. This is the second day of textbook section 7.2. So today we're going to look at rational functions in a different form. So yesterday they were like this, where all I had was a variable on top, a number on top. But now we're going to have variables on the top and the bottom. So if that's the case, we're not going to have a plus anything afterwards, first of all. For the vertical asymptote, we're going to take the denominator, set it equal to 0, and solve for x. Whatever that is my vertical asymptote. My horizontal asymptote is going to be found using the coefficients, the numbers in front of the x's on both the top and the bottom. Whatever fraction that ends up being, that's the y value of the horizontal asymptote. All right, we're still going to graph our points on either side and draw the two branches. The only thing I want to remind you is domain was all real numbers except x can't equal the vertical asymptote, and our range was all real numbers except y couldn't equal our horizontal asymptote. In this case, it's a over c. So let's get into it. We have 2x plus 1 over x minus 3. So again, I'm going to identify my vertical and horizontal asymptotes. So my vertical asymptote is what's going to make the denominator 0. So I cannot have positive 3 down there. So x is 3 is my vertical asymptote. My horizontal asymptote, I'm going to take the coefficients. So even though it doesn't show it there, there's a 1 in front of the x. So this is really 2 over 1, or 2. So if we get in our asymptotes now, we had x is 3, that would be right about here, and y is 2, would be here. All right, so that means I'm going to put 3 here in the middle, just like I did last time, as undefined, and I'm going to pick numbers before and after it. So before would be 2, 1, and 0. After it would be 4, 5, and 6. And I'm going to plug in. So if I plug in 0, that's nice. The x's go away. I'm left with 1 over negative 3, or negative 1/3, right? No real work to do for that one. If I plug in 1, 2 plus 1 is 3. 1 minus 3 is negative 2. So that ends up being negative 1.5. 4 plus 1 is 5. 2 minus 3 is negative 1. So that's negative 5. Now let's try 4. That's 8 plus 1 is 9. 4 minus 3 is 1. So that's just 9. 10 plus 1 is 11. 5 minus 3 is 2. So 11 over 2 is really 5.5. And then 12 plus 1 is 13. 6 minus 3 is 3. So 13 over 3 is 4 1/3. So I'm going to go ahead and graph these. We have 0, negative 1/3. We have 1, negative 1.5. And we have 2, negative 5. So 1, 2, 3, 4, 5. So these are going to be a little easier to draw than the ones from yesterday because they're going to give us a little more room. All right, they're not going to be as tight. So here I now have more room to go like this and get really close to it. All right, then I have 4, 9, 5, 5.5, so 3, 4, 5.5. And then 6 is 1, 2, 3, 4 1/3. And we'll give it some time there, like that. All right, so my domain was all real numbers except x could not be 3. And my range was all real numbers except y could not be 2. And that's my domain and range. Let's do another one together. So my vertical asymptote, if I took negative x minus 1 and set it equal to 0, let's say I add x to both sides, so negative 1 equals x. So that's my vertical asymptote. So I already know negative 1 is going to go here. My horizontal asymptote, if I take the coefficients, negative 3 over negative 1, that gives me y is 3. So let's graph those. We have x is negative 1, and we have y is 3. All right, if I pick three numbers before negative 1, that's negative 2, negative 3, and negative 4. If I pick numbers after negative 1, that's 0, 1, and 2. So let's start to plug it in. Let's get rid of this so I don't have it in the way. So that's negative 4 times negative 3 is 12, plus 2 is 14. Positive 4 minus 1 is 3. So 14 over 3 is 4 and 2/3. Plug in negative 3. So that's positive 9 plus 2 is 11. Positive 3 minus 1 is 2. So that's another 5.5. Positive 6 plus 2 is 8. Positive 2 minus 1 is 1, so that's just 8. 0, boom, both those are gone. 2 over negative 1 is negative 2. Plugging in 1, negative 3 plus 2 is negative 1. Negative 1 minus 1 is negative 2, so that's 1/2. And negative 6 plus 2 is negative 4. Negative 2 minus 1 is negative 3, so 1 and 1/3. All right, let's graph. So 1, 2, 3, 4. 1, 2, 3, 4 and 2/3. 1, 2, 3. 1, 2, 3, 4, 5.5. And negative 2, positive 8. All right, I just want to remind you from our last lesson, the things I'm looking for when you're graphing is that you're not curving it back and that you're not crossing over the lines that are the asymptotes. All right, here we have 0, negative 2, 1, comma 1/2, and 2, 1 1/3. All right, so there's our graph for this one. Domain and range. All right, the domain was all real numbers except x could not equal negative 1. And my range was all real numbers except x could not equal, y could not equal 3. All right, you're actually going to try the next two, so I'll put the first one up for you to try. You can pause it, and then I'll show the answer. All right, go ahead and check your answer for this one. Right, negative 3 was our vertical asymptote, and then 1 over 1, or just 1, was our horizontal asymptote. So our domain, x could not equal negative 3, and our range, y could not equal 1. All right, you go ahead and try this second one, pause it, and I will show you the answer. It's okay if it goes off the graph. All right, here's our second one. Negative 1 would make the denominator 0, so x equals negative 1 is our vertical asymptote. 3 over 1 is 3, so y is 3 is our horizontal asymptote. So the domain is x cannot equal negative 1, and the range is y cannot equal 3. All right, the last thing we'll look at is a word problem. So here we have a 3D printer, builds up layers of materials to make three-dimensional models. Each deposited layer bonds to the layer below it. A company decides to make small display models of engine components using a 3D printer. The printer costs $1,000 and the material for each model costs $50. How many models must be printed for the average cost per model to fall below $90? So we're going to look at the cost it takes to make anything. So it's $1,000 no matter what, and every single model is $50. So that would be 50x plus 1,000 is their costs. And if we're talking about the average, we would take the total costs and divide it by how many models are being made. So this is a rational function, and we're looking for the average to be 90, right? They want it to fall below 90, so anything more than what they make here will fall below 90. So really, I have an equation that I can cross multiply, right? 90 times x equals 50x plus 1,000. If I subtract 90x, I get 40x equals 1,000. So x is 25. So after 25 models, the cost will go below $90 per model. So what's going to happen to the average cost as more models are printed, right? It's going to go down. It will lower because that $1,000 is being spread out more evenly among the models. It will lower. And really, we're approaching a horizontal asymptote. So the horizontal asymptote would be 50 over 1. So it will approach, but never go past $50, right? Because that was our horizontal asymptote. All right? So you're going to try the next one. Same concept, $50 per model, but now we're going to change the cost of the printer. So you're going to try this. It's still $50 per model, and we're still looking for the average to go to $90. So go ahead and try this one, pause it, and I will show you the answer. All right, so the only thing that's going to change is we're going to replace the 1,000 with 800. So we end up with an x value of 20, which means after 20 models, the average will be below $90. And that is the second day of section 7.2.